Hi folks, this is my second video on Open CyberSecurity Schema Framework. In last video we had covered an overview of Open CyberSecurity Schema Framework, and in this video we will cover OCSF Server specifically and look at it how we can use this to generate schema and sample data, perform JSON validations. We would also understand the need for it. Why do we need OCSF server for this process? Why can't we do it otherwise? We would also do a quick walkthrough of code generation routine. Now, let's first look at the schema, the categories, and how things are. So last time we saw, briefly on this. So to begin, there are about 9 categories that have been defined out there, and there are various classes in which, and for the sake of understanding, we'll pick one because going through everything will be very tedious. So let's take one. This is very simple one because there's only one out here in the findings category called security findings. So this is the class which is there as defined as part of the Open CyberSecurity Schema Framework. So let's look at it from a perspective, what do I need to do in order to generate the schema? So let's first have a look at this from the website, documentation website. Out here, they've defined the category, findings category, and this case security finding is the class. This is the code of the class. And there are various attributes. Some of these attributes are also sub objects. So like for example, if you look at compliance detail, this is an object in itself. Going back, there are other critical ones like enrichment, finding details, malware, metadata, observable arrays, products, things like that. If you look at finding details, it carries the information about the finding that we are covering in this security finding class. Now, as a coder, as a developer, if we have to use this schema, it is a tedious activity, honestly speaking, to translate this into a JSON-like structure. The first option that I thought of was, let's look at the schema and let's see if we can use it. So for the reference, let's go relate both of these things. So we're talking about findings category. So these are basically events, and events are classes. That's what we discussed about in the last session also, or last video out there. So we are right now in the events. In the events, we'll find findings, and this is the security finding JSON. Can we use it directly? I'm sorry, we can't. At least I couldn't find a standard way to do so, because it has a lot of correlation with other JSON files. Let's take an example. It's talking about profiles cloud. It includes attributes from profiles/cloud.json. It is extending base event. So if we go back to base event, so this is the base event class, which again carries or includes attributes from occurrence, classification, and profiles cloud. Apart from that, it has its own attributes. So it is like exercise juggling between all these, and considering that fact that these are changing and these are like not something that you could expect to keep it for once. Like for example, this is cloud is actually coming from a profiles folder. It's a profile, so you have to understand where this data is going to come in. So attribute out here is cloud, and it is a required attribute. So what other options do we have? Let's look at it. So there's an option to generate schema from here. Let's try generating the schema from here. It is going to take some time. And Let's go to the bottom of this response, have this entire response. Let's use JSON editor. So let's paste this document out here. So it has exported about 100 odd classes, objects and types. By the way, there are a lot of things you'll find in dev slash. So these are all under development classes. Let's try to create schema only for cloud, and let's see if it makes any difference. No, not really. It is still creating data for it. So now let's look at security finding. Okay, where is it? Do you see it? I don't see it. Yeah, so this is security finding. So it has attributes. My interest is specifically, let's look at findings. Okay, now this is where the challenge comes with even after generating schema. This does not contain reference to the sub attributes of the findings object. Let's look at this. So we have findings category. If you go to the finding details, and the findings object has like confidence, creation time and all those things, whereas if you look at the schema, this only talks of finding details as an object. So this is good from the documentation point of view, and maybe they are using this for documentation, but reality is that we're not able to get more information. So what else are we left with? So after trying all this, I realized this is not going to work for me. So a better option that I could figure out after all this is to use a sample data instead of exporting schema. So sample data. So let's use the sample data, try it out. Class name is equal to security underscore finding. By the way, sorry, I missed out on a very important thing. How would you know which class name to use? This is very easy, honestly speaking. You can go to your schema and click on this one, the class that you want to achieve, and you'll find the value coming out here, security finding. Just use that one, and you should be good to go. So we have used this, pasted it here, execute. Now this is like quick one. Copy this. Let's delete this. So let's look at this. So what they've done is they've created some sample data for us. We have some information and some metadata. Let's try to generate data 2 times, and let's see if we get similar structure, because I observed a difference when I was trying it earlier. Since this code is under continuous development, there's a probability that it could have changed. So let's look at it. So they have activity ID, cloud, 1, 2, 3, 4, 5, 6, 7. No, they are still randomly generating the data. Not everything will have, every sample data generation will have same thing. So if we collapse all, out here, collapse out here, 29 attributes. So we're getting cloud enrichments. We don't find enrichments out here. We do not find vulnerabilities out here. So how do we go about it? That was a very big challenge again, because in order to understand how to use data, it is important that we look at it in a holistic manner. So The next step in the process was to do a deep dive into the code itself. Try to look at the routine. So this is the generator routine, which is there, which I have modified of the OCSF server code. I'll show you where the difference is. So they're only generating 80% of recommended fields as part of sample data, 50% of optional fields as part of sample data, and similarly they're using randoms at various places to generate partial data because it's a sample data and it may or may not be applicable in all the cases. So I decided to comment these sections out and generate more thorough data, and this was the reason why I modified the code to run. Let's look at another thing, which is to perform the validation. Let's take this as an example. Let's go back to the Swagger UI, go to API validate, try it out, paste the sample data, execute. So wow, this is interesting. The data has been generated, but the array contains invalid data. So it is CVSS object. It says access complexity, undefined attribute name. Yeah, so if we go here, I'll tell you, they are using only ID numeric numbers. The details, CVSS codes. So the object should only provide underscore ID. So these are all supposed to be integers, and there are no string values that we need to provide. Honestly speaking, probably the code generation routine has some bugs which is causing this issue. So for testing, let me just quickly remove these values which I know should not be there. Oops. Required impact ID integrity modified strings are not required. So vector string is supposed to be actual string, honestly out here. Let me execute and let's see if still there is. So we've seen it is performing validation primarily on data types. Honestly, that's my observation at this time and not the actual data. Like for example, this vector string by no means is a valid CVSS vector string, but it is still doing the validation, and I assume, considering the fact that this is still in development, they'll improve upon it as time passes by. So far it has been helpful for me to understand more, and I'll probably continue watching the developments and share more with you in future if I find something interesting. So we have covered how to generate schema, though it may not be that much of help at this point in time because it is not thorough. It does not cover the entire hierarchy, which is the case with the files the way they are structured. We are able to generate sample data. Sample data does provide the data in a hierarchical structure. However, considering the fact that there is a randomness they are using for generation of data, not all optional attributes or recommended attributes would be visible as part of sample data. We can perform JSON validation using the validate API, but that is again limited to the data type validation at this point in time. We did a quick walkthrough of the generation routine and looked at it how we could comment out certain sections to generate more data as part of the sample data. One thing which I missed out on was how to access Swagger UI for performing all these validations or operations. Is that you can visit the schema website and you can click on API doc out here. So this is schema UI is a good piece of tool that one can use. You can see the JSON out here. So I think that covers the video for today. Do let me know what are your thoughts, what direction should OCSF proceed, and anything else that comes to your mind. Thank you very much.